Welcome to Engineers Mindset. Today we'll start a series on thermodynamics. Now, what is thermodynamics? Thermodynamics is a branch of engineering and science which deals with the study of properties of matter as they are being affected by changes in temperature. The branch of engineering and science which deals with the study of properties of matter as they are being affected by changes in temperature. Now, thermodynamics is actually a compound word made up of therm. It's actually a compound word made up of therm, which means heat, and dynamics, which means force. So we can also think about thermodynamics as the action of the force of heat. It can also be thought as the action of the force of heat. Now we're going to be talking about different concepts in thermodynamics. And the first concept we'll talk about, as being listed out here, we'll talk about the thermodynamic systems and types. Okay, so what is a thermodynamic system? What is a thermodynamic system? A thermodynamic system is simply a fixed quantity of matter in space whose behavior is under investigation. It's simply a fixed quantity of matter in space whose behavior is under investigation. For instance, let's say I have a cycle and there is a quantity of matter, let's call this water, present in this system, and I am undergoing an investigation in that system. In that case, this is called a system. Remember, a fixed quantity of matter in space whose behavior is under investigation. So if the behavior of the system is not under investigation, then it is not a thermodynamic system. Now let's say I have a cup of tea. Let's say I have a cup of tea or a cup containing hot water. Let's say I have a cup containing hot water, and then I put in my mixtures of tea, like your milk, your Milo, your sugar, your chocolate, and all that into the container. At first, the milk, the chocolate, the sugar all will settle at the bottom of the cup until I bring in a teaspoon and stir them together before they mix. In that case where I'm stirring, I am undergoing what is called an investigation on the system to check if it is sweet or is not sweet. That's a good example of a thermodynamic system. So if the behavior of the property of matter is not under investigation, then it is not a thermodynamic system. Now, there are lots of things to study on this. This is a system which is under investigation. Let's say we have water in this system and we want to investigate if this water contained or in this region of space is movable or is fixed. In that case, we are running an investigation on the system. In that case, that is called a thermodynamic system. Now, notice that since this property of matter is called a system, there is a separation from every other world. Let's say we have the surrounding. This is the surrounding. Let's say we can have air around. So this separation is what is called boundary of the system. We call this boundary of the system. While the air which is around the system, we call that surrounding. It's called surrounding. Okay, so we cannot talk about thermodynamics without this extra tool. For instance, the cup of hot water or the cup containing a tea, the cup itself is what? Is a boundary. The cup is a boundary. While if the tea is hot, if the tea is very hot, notice that by induction, if you bring your hands close to the cup without touching the cup, you feel the heat of the cup outside the air surrounding the cup. So every other thing outside that cup that is not being touched by the cup directly but outside the cup is what we call surrounding, just like you can see here. So for the teacup, the cup itself is the boundary. The tea itself is the system. and every other thing outside is called what? Surrounding. Alright, so let me explain what a boundary is. A boundary is simply the separation between a system and the surrounding. A boundary is simply the separation between a system and the surrounding. As you can see, this is a boundary, while the system is contained inside of the boundary. So that separation between the system and the surrounding is what we call the boundary, as can be seen for the case of a cup of tea. Meanwhile, the surrounding is everything outside the system. Everything outside the system that responds to the changes that takes place in the system. Everything outside the system that responds to the changes that takes place in the system. I give an instance that if the tea cup is very hot, if the water in the tea in the cup is very hot, if you bring your hand very close to it without touching the cup, you feel the heat. That's by induction. You feel the heat. That means the heat inside the cup is also being felt outside. In that case, everything outside of the system that is being affected by what is happening inside the system are what we call thermodynamic surroundings. Alright. Now the next thing we'll talk about are types of systems. Basically, in thermodynamics, we have just two types of systems. We have what is called the open system and the closed system. Okay, so a system can be broken into two. We have the open system and we have the closed system. Okay, we have the open system and we have the closed system. Now, what is an open system? A system is said to be an open system when the quantity of matter contained in the system, in addition to energy in the form of heat and work, can cross the boundary of the system. That's it. So when water can simply flow out of the system, it is called an open system. That's what it means in this guys. If quantity of matter contained in the system can easily flow out of the system, can easily flow across the boundary of the system, then such a system is called an open system. A good example is your tap, your water tap that you have in your house. Okay, once you turn on the valve, what happens? Water starts flowing. In that case, the system is said to be open because the tap itself is a boundary. The valve is an open. So once you open the valve, it means you have now removed the restriction between the path of the flow of the fluid. So water starts gushing out from the tap. So when fluid or when the quantity of matter can flow in and out of the system, then we see we have an open system. While a closed system is a system in which only energy in the form of heat and work can cross the boundary of the system. That simply means that the quantity of matter is not permitted to cross the boundary between a system and its surrounding. So a closed system is that system in which the quantity of matter cannot cross the boundary between the system and its surrounding. Only energy in the form of heat and work can cross the boundary between the system and its surrounding. Open systems are also called control volume. Open systems are also called control volume. So take note of this. An open system is also called control volume. We call a closed system also as control mass. So a closed system can also be called control mass. So this is for open system, open, and this is for closed system. Okay, so an open system can be called also a control volume, while a closed system can be called a control mass. And when we use control volume and control mass instead of open systems and closed systems, then the boundary at that point is called control surface. The boundary is called control surface. It's called a control surface. Alright. Okay, so we talked about the system, we talked about types of system. Now we notice that I said we can't talk about the system without surrounding You can't also talk about a system without boundary. Now, I've told you that the boundary of a system is simply the separation between the system and the surrounding. There are different kinds of boundary. We have what is called a real boundary. We have what is called a real boundary. Okay? A boundary is said to be a real boundary when the boundary can be seen, felt, or touched. We call it a real boundary. If you can see the boundary, if it can be seen, if it can be felt, it can be touched, then it is called a real boundary. For instance, let's also go back to tap. The water tap is a good example of a real boundary because you can touch the tap, you can feel it, you can see it, so it's called a real boundary. Okay? Another kind of boundary that we have is what we call imaginary boundary. A boundary is said to be imaginary if it cannot be seen, it cannot be felt, it cannot be touched. You can only imagine it. So it's called an imaginary boundary. When it cannot be seen, it cannot be felt, and it cannot be touched. A perfect example of an imaginary boundary is the envelope that guides a steam coming out from a boiling water in a kettle. You notice that when a kettle is boiling, the steam that comes out from the mouth of the kettle follows a certain direction, a certain channel. Let me see if I can draw. Okay, so let's say we have this to be our kettle. So let's say we have this to be our kettle, and this kettle happens to be what? Boiling. This is heat. Notice that the steam that comes out from the mouth of the kettle follows a certain direction before it disappears into the atmosphere. There is an envelope before it disappears into the atmosphere. This envelope that covers the steam, this envelope that guides the steam is a boundary. But that boundary cannot be seen, it cannot be felt, it cannot be touched. So it is called an imaginary boundary. So that's a perfect example of an imaginary boundary. The boundary that guides the envelope that guides the steam coming out from the boiling kettle is a perfect example of an imaginary boundary. Okay. Another type of boundary is what we call fixed boundary. A boundary is said to be fixed. A boundary is said to be fixed when the quantity of matter which is under investigation cannot move. It can't change position, it can't increase in volume, it can't change orientation. Such a boundary is said to be a fixed boundary. When the boundary of the system is not permitted to move, change in size, increase in volume, but remains in one position, in a static position, such a boundary is said to be called a real boundary. You can as well use your tap, because your tap measuring is static, it doesn't move. Okay, so you can use that as an example of a fixed boundary because it doesn't move, it remains in one position. That's a fixed boundary. And then the final type of boundary that we have is what we call the movable boundary. Okay, so a boundary is said to be movable when it can change in size, increase in volume, change orientation. Such a boundary is said to be what? A movable boundary. Okay, when the boundary can change in size, change orientation, increase in volume and all that, then we call it a movable boundary. Alright, so that being said, we'll talk about another property in thermodynamics which is called thermodynamic properties and classification. So we'll go to the next concept in thermodynamics, which is thermodynamic properties and classifications. So what are thermodynamic properties? A thermodynamic property can be defined as the macroscopic characteristics of a system. When you say macroscopic, a very tiny characteristics of a system to which a numerical value can be assigned without knowledge of the history of the system and its investigation. Without knowledge of the history of the system and its investigation. So in general, what we are simply saying is that thermodynamic properties are simply what those properties that make up the thermodynamic system. That's all. They are simply properties that make up thermodynamic system. Examples of thermodynamic properties are pressure. We have pressure. We have temperature. We have volume. And we have energy. Okay, so these are simply what properties of a thermodynamic system. Now, classifying a thermodynamic system, thermodynamic properties. Thermodynamic properties can be classified first by their variability with mass. Under this condition of classification, we have two properties. Under this condition, we have two properties. We have what is called the intensive and extensive properties. Okay, under variability with mass, we have what is called the intensive and extensive properties. Now, what is an intensive property? An intensive property is that property of a system which do not respond to changes in mass, or there are those properties of the system that do not change with respect to mass. That's what an intensive property is. The property of a system which do not change with respect to mass. They are called intensive properties. Example of such properties include pressure and temperature. Pressure and temperature. Okay, we have them here, pressure and temperature. These are good examples of intensive properties. They do not change with respect to mass, so they are called intensive properties. On the other hand, extensive properties are those properties whose value changes with respect to mass. So we call them extensive properties because their value changes with respect to mass. And a good example of extensive properties are volume and energy. Volume and energy are good examples of extensive properties. Their value always changes with respect to mass. Now, if the value of an extensive property changes with respect to mass, then we can also call it specific properties. So take note, extensive properties can also be called specific properties. And in thermodynamics, we use capital values or capital symbols to represent intensive properties, while we use smaller symbols to represent specific or extensive properties. For instance, a specific property of volume, specific or extensive property of volume is simply what small letter v, because the unit is meter cube per kilogram. So take note, we always divide the extensive properties by mass. That's what we mean by the value changes with respect to mass. So it means the original value divided by the mass. That will give us what is called the extensive or the specific properties. So whenever we are dividing the original value by mass, we have the extensive properties. So for instance, this specific property of volume V is simply total volume divides by mass. So we can call this capital V divided by M. Okay, so that's how we have meter cube for the unit of volume, kilogram for the unit of mass. So the unit is meter cube per kilogram. We can as well call extensive properties what? Specific property. Okay, so that is that about variability by mass. Now, thermodynamic properties can also be classified according to another mode of classification of a thermodynamic property is to ability to directly measure them. By the ability to directly measure them. Under this classification, we have what is called the primitive properties and the derived properties. I think you should look that up for yourself while we go to the next concept in thermodynamics, which is thermodynamic states. Next concept in thermodynamics is thermodynamic states. What is a thermodynamic state? A thermodynamic state simply defines the condition of a system at a particular point in time. It defines the condition of a system at a particular point in time. So we have the initial state and the final state and blah 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 and blah. Alright, so the next thing we'll talk about is what we call thermodynamic process. What is a thermodynamic process? A thermodynamic process is simply any activity within the system that causes the system to change position from one state to another state. We have what's called a process. Any activity within the system that causes a system to change position from one state to another state, then we have what is called a process. So when the system moves from initial state to final state, we have encountered a process. That's what thermodynamic process is all about. Now, another thing we'll talk about is classification of thermodynamic process. How do we classify thermodynamic process? The first way to classify thermodynamic process is by the kind or the type of system involved. We can classify the process first by the type of system involved. Okay? This is what I mean by type of system involved. Okay, recall that we have two types of systems. First, an open system, and second, a closed system. So, for an open system, we have what we call a flow process. For an open system, we have a flow process. Okay, for an open system, we have what is called a flow process. So if the thermodynamic system at that point is an open system, then the process is called a flow process, simply because open systems permit the quantity of matter in addition to energy in form of work and heat to cross the boundary. So there is a flow across the boundary of the system. So for an open system, we have what is called a flow process. Whereas for a closed system, we have what is called a non-flow process. So if the system is a closed system, we have a non-flow process. So first of all, we can classify a thermodynamic process first by the kind of system involved. For an open system, we have a flow process. For a closed system, we have a non-flow process. For an open system, if the system is open, then we have flow process. Okay, if the system is a closed system, then we have a non-flow process. Okay, so that's the first classification of thermodynamics. The next way to classify thermodynamics is by the condition of the state. By the condition of the state. That is the relationship between the initial state and the final state. That's it. It can be classified by the relationship between the initial state and the final state. Okay? Okay, by the relationship between the initial and final state. That's the second way of classifying the thermodynamic process. Now, what does this mean? If the initial state and the final state are equal, then we have what is called a cyclic process. Cyclic process. If the initial state of the system is equal to the final state of the system, then it means we have what is called a cyclic process. But if the initial state of the system is not equal to the final state, then we have what is called a non-cyclic process. So that's another way of classifying a thermodynamic process, by the condition of the initial state and the final state. If the initial state and final state are equal, then we'll have a cyclic process. But if the initial state and the final state are not equal, we have what is called a non-cyclic process. Finally, another method of classification of a thermodynamic process is they can be classified as reversible or irreversible. Or irreversible process. Sorry, this is D. Okay, so thermodynamic process can also be classified as reversible or irreversible processes. Now, a thermodynamic process is said to be reversible if the final state of the system can be brought back to the initial state of the system by doing the exact process of the opposite of what was done in the forward process without a residual of energy. Without a residual of energy. In that case, we have a reversible process. But it is not possible in real life to have reversible processes. It's not possible. So reversible processes do not exist in real life. Anyways, but if the process, if the final state of the system, if the final process cannot be brought, if the final state cannot be brought back to the initial state of the system, then it is called an irreversible process. So these are the three ways in which you can classify the thermodynamic process. Okay, so let's talk about heat and work. Let's talk about heat and work. Of course, in mechanics, there's a little bit difference in definition of heat in terms of mechanics and work, and then definition of heat and work in terms of thermodynamics. There's a little bit different, but they are all virtually the same thing. Now, what is heat in thermodynamics? Heat is a transient form of energy that is found at the boundary between a system and its surrounding by virtue of temperature difference. Heat is a transient form of energy usually found at the boundary between a system and its surrounding by virtue of the temperature difference between the system and the surrounding. That is what is called thermodynamic heat. Now, what is thermodynamic work? Just like heat, work is also a transient form of energy found at the boundary between a system and its surrounding by virtue of pressure difference. It's taken by virtue of pressure difference. In terms of heat, is by virtue of temperature difference between the surrounding, the boundary, and the system. While in terms of work, is by virtue of pressure difference between the boundary and the surrounding. Now let's try to do a little bit derivation of the formula for work as applicable to thermodynamics. So let's say we have a fluid in a cylinder that is being compressed by the cylinder head. Let's say we have a fluid in a cylinder, something like this. Okay. And then we'll apply pressure by this cylinder, and there's a change in position. Let's say the initial position is x1, and the final position is x2. So let's say we'll have a cylinder compressing a fluid from x1 to x2. It means therefore that difference or distance traveled, the x has changed in distance is simply x2 minus x1. So let's say we have this. You recall in mechanics, recall that work done is force times distance traveled. According to Newton's law, work done is simply force times distance traveled. That's the mechanics. Okay? Recall that, but you know that pressure P is equal to force all over area. We know this. So if we make force the subject of the formula, it means that force F is simply pressure times area. If we make force subject, force is simply pressure times area. So in place of force, let's call this equation 1, let's call this equation 2, let's call this 3, or let's call this equation 3. So in place of force in equation 3, let's substitute the work done in equation 2 above. So we are going to have that work done is equal to, in place of force, we have pressure times area. So this is pressure times area times the S. Because force is pressure times area times work done is force times distance. So you have this. Alright. Okay, so with this, you know that volume is simply what area times the x. That's area times length will give us volume. So this is equal to this in meter. This is simply what volume V. So it means that the work done in thermodynamics is actually pressure times volume. So in thermodynamics, work done is simply pressure times volume. That's the work done in a system. It's simply pressure times volume. Now, if there is a difference in volume, let's say we have initial and final conditions of volume, that's a change in state of the system. If there is a change in state of the system, then work done at that point is now an integral value. Work done is equal to an integral from initial volume to the final volume of pressure times change in volume. So this is what we use for our calculations on work done in thermodynamics. Okay, so before I run this up, I'm going to take us through sign conventions applicable to this video. I don't know if it's applicable to your school or your institution, but I know majority of schools and textbooks, including Raj schools, adopts this same sign conventions. So we are going to be talking about sign conventions, which is the last thing on the course of thermodynamics we are going to explain today. Sign conventions. Now, the sign conventions includes this. 1. When a system receives heat, that heat is positive. Because when a system receives heat, it increases in size. Just like you take a lighter and then you turn it on close to a rubber. What happens? The rubber extends in size, starts to increase in size. So heat supplied to the system is positive. That's the first sign convention. When heat is removed from a system, then heat at that point is negative. So heat removed from the system is simply negative. So take note of that. That's the second sign convention. Third sign convention, work done on a system, please take note, work done on a system is negative. That is to say, when work is done on a system, that work is a negative work. But first sign convention, when a system does work on the surrounding, that work is positive. So take note, work done on a system is negative, while work done by a system is positive. So in general, I've defined 4 sign conventions. These sign conventions are going to guide us throughout our calculations in thermodynamics work. Alright, so thank you guys. That's it on the introduction of thermodynamics. In the next video, we'll start calculations on thermodynamics work. Please ensure you watch the video to the end, follow the series for chapter 1 in thermodynamics till we'll get to the next topic in thermodynamics. That's it, guys. If you're new to the channel, don't forget to subscribe, and also don't forget to like and share the video. Inform your friends, tell them something great is happening on this channel. I hope to see you in the next video. Thanks and cheers.